We live in a world where information pursues us everywhere. A smartphone in our pocket, a smartwatch on our wrist, a laptop in our bag. Our brain is never left alone. Every second, it processes 5 times more data than 20 years ago. What happens to our attention and memory under these conditions? They transform, adapt, sometimes break. Our brain, which evolved over millennia to survive in the wild, is now forced to cope with a flood of notifications, emails, and an endless news feed. We notice that it has become harder to focus on one task, more difficult to remember names and dates. Our brain seems to have switched into a constant scanning mode instead of deep immersion. But does this mean that we are losing important cognitive skills, or perhaps gaining new ones? The main question today is how to adapt our brain to the challenges of the digital age while preserving its unique abilities. 100 years ago, the average person could concentrate on a single task for hours. Imagine a Victorian scientist bent over a manuscript, or an engineer designing a bridge with a slide rule. Their attention was deep, focused, linear. Books were read cover to cover. Letters were written without distractions from notifications. The brain functioned in a state of deep immersion, a state that neuroscientists today call deep focus. Studies show that in the 1980s, the average attention span for a single task was about 15 minutes. By the 2000s, it had shrunk to 5 minutes. And now, 8 seconds, less than a goldfish. We have transformed from attention marathoners into sprinters, constantly switching between tasks. Our brain has reconfigured itself for multitasking mode. It has learned to quickly scan information, snatching key fragments. This ability has evolutionary value in a world of information abundance, but it comes at a price. Neurophysiologists from Stanford University found that frequent attention switching depletes the prefrontal cortex, the brain region responsible for decision-making and deep thinking. Each switch is a cognitive price we pay without noticing. Interestingly, people who consider themselves effective multitaskers actually focus worse and are more easily distracted, according to research. Remember how we used to memorize phone numbers? And now, why bother if they're stored in a smartphone? This is a vivid example of what scientists call the quote, a phenomenon where the brain stops memorizing information that can be easily found in external sources. Our memory is gradually transforming from a repository of facts into a navigation system. We increasingly rarely remember the fact itself, but we perfectly remember where to find it. Studies by Columbia University showed that when solving complex problems, people first think about the computer and then about the content of the problem. Our brain has literally reprogrammed itself. It no longer expends resources on memorizing dates, formulas, or historical events. Instead, it remembers the path to this data, in which application, on which website, or in which folder it is stored. This is an evolutionarily justified strategy. The brain always strives for energy efficiency. But what do we lose by delegating memory to external devices? Neuroscientists warn, without regular memory training, the neural connections responsible for memorization weaken. It's like a muscle that atrophies without exercise. Even more alarming is that external data storage changes the very quality of our thinking. When information is stored in our head, it becomes part of a complex associative network, generating creative ideas and unexpected insights. Google doesn't provide that. Perhaps we are on the verge of a cognitive revolution, when our memory will transform into a fundamentally new system, a hybrid of biological and digital intelligence. Our brain possesses an astonishing property: neuroplasticity. This is the ability to restructure itself in response to new experiences and stimuli. When we learn a new skill, new neural connections form in the brain. But what happens when we scroll through an Instagram feed for hours, or switch between a dozen tabs in a browser? Neuroscientists from the University of California have discovered that intensive use of digital devices literally reshapes our brain. Using MRI scans, they found that active smartphone users show an increased cortical area responsible for thumb movements, and in gamers, areas responsible for spatial orientation and quick decision-making expand. The brain adapts by strengthening the neural pathways that are used more frequently. This is a two-way process. When we spend time on some activities, other areas of the brain receive less stimulation and may weaken. Studies show that people who spend more than 6 hours a day in front of screens have a smaller volume of gray matter in areas responsible for self-control and empathy. Neuroplasticity works both in a positive and a negative way. Japanese scientists have found that children who regularly read paper books have better developed brain areas responsible for understanding others' emotions, compared to those who primarily consume content from screens. Our brain is not a static organ, but a dynamic system that constantly reshapes itself under the influence of the environment. Our brain processes an amount of information equivalent to 3,000 newspapers daily, a figure that would have seemed incredible 30 years ago. We live in an era of cognitive overload, where informational noise has become a constant backdrop to our lives. Every social media post, every email, every notification, all of this demands a microdose of our attention. This results in a phenomenon neuroscientists have termed digital fatigue. This is a state where the brain is literally exhausted from the constant need to filter and sort incoming information. Studies show that by the end of a workday filled with digital communications, our decision-making ability decreases by 40%. The brain enters a resource-saving mode, shutting down the prefrontal cortex, the area responsible for complex cognitive processes. Nature designed our brain with an amazing information filtering system. The reticular formation, a structure in the brainstem, acts as a gatekeeper, allowing only significant signals into consciousness. But this system evolved to filter physical threats and opportunities, not an endless stream of digital stimuli. As a result, the filters become overloaded, and we lose the ability to distinguish what is truly important. Interestingly, our brain reacts to information overload in the same way it reacts to physical danger, with a release of cortisol, the stress hormone. Chronically elevated cortisol levels literally destroy neural connections in the hippocampus, the area responsible for forming new memories. This is why on days when we scroll through news feeds for hours, it's so hard for us to remember anything new. Have you ever noticed how hard it is to tear yourself away from the endless scroll of TikTok or Instagram? This is no accident. Behind every social platform stands an army of engineers, psychologists, and designers whose task is to capture and hold your attention for as long as possible. We live in an age of the attention economy, where our cognitive resources have become the main currency of the digital world. User attention is what social networks sell to advertisers. The longer you stare at the screen, the more ads can be shown to you. The business model is simple and ruthless. Your time is converted into profit. Carefully designed psychological mechanisms are used to hold attention. The variable ratio reward system, the same principle that operates in slot machines, makes us endlessly check notifications. We never know when we'll get another dopamine hit from a new like or comment. Every red notification on an app icon is a microdose of anticipation, a tiny surge of neurotransmitters that forms a genuine addiction. Social media algorithms study our behavior with frightening accuracy. They know which videos we linger on, which posts elicit an emotional reaction, and they adjust the feed to maximize our engagement. our attention is fractured into tiny fragments, 15-second videos, short posts, instant reactions. We become accustomed to constant stimulation and begin to feel discomfort in silence and in the absence of digital irritants. This forms a new type of attention, scattered, fragmented, constantly seeking a new dose of informational stimulation. The evolution of our perception of information has taken a radical turn. From text to video. Just 30 years ago, books, requiring linear, sequential comprehension, were the primary source of knowledge. Today, video content has become the dominant format for information consumption, and this fundamentally alters our cognitive landscape. The human brain processes visual information 60,000 times faster than textual information. We are literally programmed to perceive moving images. Neuroscientists at MIT have discovered that entirely different neural networks are activated when watching videos than when reading. The visual cortex is maximally engaged, while areas responsible for critical thinking often remain passive. This leads to the formation of so-called clip thinking, the ability to quickly perceive vivid images, but with difficulty in constructing complex logical chains. Short videos on TikTok and YouTube Shorts amplify this trend. Our brain becomes accustomed to a constant change of bright stimuli and begins to experience discomfort when prolonged concentration is required. Interestingly, the average video viewing time over the past 5 years has decreased from 4 minutes to 40 seconds. It's as if we are unlearning how to sustain attention on one thing for longer than a minute. However, visual thinking also has its advantages. It allows us to instantly grasp images, process large amounts of information faster, and better remember emotionally charged scenes. Multitasking is a myth. Such a statement might seem strange in a world where the ability to juggle multiple tasks simultaneously is considered almost a superpower. However, neuroscientists are categorical. Our brain is physically incapable of performing several cognitively complex tasks at once. What we call multitasking is actually a rapid switching of attention. Every time we interrupt working on a report to check email and then respond to a message in a messenger, our brain performs a series of micro-switches. And each such switch comes at a price. Studies from the University of California have shown that after each interruption, it takes us 23 minutes to fully return to the original task. At the same time, the probability of making a mistake increases by 50%. This happens because switching is an energy-intensive process for the brain. When changing the focus of attention, the prefrontal cortex must unload the context of one task from working memory and load the context of another. This process consumes glucose and oxygen, valuable resources that the brain often lacks by the end of the workday. Interestingly, people who consider themselves effective multitaskers show worse results in attention-switching tests. They are more easily distracted and are worse at filtering irrelevant information. It turns out to be a paradox. The more we practice multitasking, the worse we become at managing attention. Where did I save that file? What was the password? What was that book called? These questions have become part of our daily lives. We are experiencing an era of digital amnesia, a state where the brain refuses to remember information that is available with a single click. A study by Kaspersky revealed shocking statistics. 70% of people cannot recall their children's phone numbers, and a third do not remember their own spouse's number. We have delegated memory to devices, and our brain has quickly adapted to this reality. Neuroscientists from Oxford University found that when solving tasks, we first recall not the information itself, but the path to it, in which device, folder, or application it is stored. This is a fundamental change in cognitive processes. The mechanism for forming long-term memory, requires active recall and mental effort, what psychologists call desirable difficulty. When we rely on external storage, these mechanisms atrophy. Particularly concerning is the change in memorization strategies among digital natives, the generation that grew up with smartphones in their hands. Experiments at Stanford University showed that they demonstrate excellent information retrieval skills, but perform significantly worse on tasks requiring factual retention. Their brains form not an encyclopedia of knowledge, but a catalog of links, where and how to find the necessary data. This is an evolutionarily justified strategy in a world of information abundance, but it comes at a price. Imagine your digital world as a garden. It requires regular care and attention. Digital hygiene is a set of practices that help you maintain control over the information flow and protect your attention from constant distractions. Start with a simple audit of your digital environment. How many apps on your phone do you actually use? Which notifications are truly important? Studies show that the average smartphone user receives over 150 notifications a day, each of which is a micro-interruption in concentration. Disable all non-essential alerts. Designate 2 or 3 time slots a day for checking email and messages instead of reacting to every signal. Create digital boundaries, physical and temporal zones free from devices. A gadget-free bedroom improves sleep by 30%, and the first hour after waking up without checking messages significantly reduces anxiety levels throughout the day. Organize your digital space. Delete unnecessary apps, tidy up files, use folders and tags. Cognitive psychologists state that external order reduces mental load and frees up resources for important tasks. Practice information fasting, regular periods of complete disconnection from the digital world. Even 24 hours without the internet restore the ability for deep concentration and reduce cortisol levels, the stress hormone. Remember, digital hygiene is not about rejecting technology, but about conscious and balanced use of it. Our brain, like any muscle, needs regular training, especially in an era when digital technologies are taking over more and more cognitive functions. Neuroscientists from Cambridge University have proven that targeted exercises can not only preserve but also enhance our cognitive abilities, even amidst information overload. Let's start with attention training. The Pomodoro technique, working in 25-minute intervals with 5-minute breaks, increases concentration by 40%. The practice of deep reading, at least 30 minutes of continuous immersion in a complex text without distractions, restores neural pathways responsible for sustained concentration. Mindfulness meditation, just 5 minutes a day, enhances the activity of the prefrontal cortex, helping to resist digital temptations. For memory strengthening, the active recall technique is effective. Instead of rereading material, try to reproduce it from memory. Research shows this strengthens neural connections in the hippocampus 60% more effectively than passive repetition. The spaced repetition method, returning to material at increasing intervals, consolidates information in long-term memory. For developing working memory, mental calculations and memorizing sequences are useful. Surprisingly, even physical activity is critically important for cognitive functions. A 30-minute walk increases blood flow to the brain by 15%, improving all aspects of thinking. The future of human cognitive abilities lies not in opposing technologies, but in a harmonious symbiosis with them. We stand on the threshold of a new era, an era of cognitive partnership between the human mind and artificial intelligence. A key factor in this alliance becomes mindfulness, the ability to choose when to use technologies and when to rely on one's own cognitive resources. Technologies should enhance our intellect, not replace it. Just as glasses improve vision without negating the ability to see, digital tools should expand the possibilities of thinking while preserving its unique qualities. Researchers at Oxford University are developing the concept of extended cognition, where devices become a natural extension of our mind. In this paradigm, we use external information storage systems for facts and data, freeing up biological memory for creativity, emotional intelligence, and critical thinking, areas where humans still surpass machines. Next-generation neurointerfaces will allow direct connection to information systems, making interaction with data intuitive and instantaneous. At the same time, it is critically important to preserve the capacity for deep thinking, the type of cognitive work that generates innovations and breakthroughs. This will require a new educational paradigm, where the focus shifts from memorizing facts to developing metacognitive skills, the ability to learn, adapt, and integrate knowledge from different fields. The future belongs to those who can balance digital efficiency and human depth, between the speed of information processing and the wisdom of its comprehension.